Imagine this. Outside your windows, it's -40. A freezing storm is knocking you off your feet, and the ground is frozen, solid hundreds of meters deep. In conditions like these, any construction mistake doesn't just mean huge utility bills. It's a real threat of freezing to death. But the people of Greenland have lived here for centuries, and today they build modern homes that trap heat with the efficiency of a thermos. How do they pull it off? How do they manage to save every single kilowatt where nature itself is designed to freeze you out? Today, we're going to break down Greenland's engineering secrets, from ancient ideas to modern space-age technology. Let's dive in. Historical hardcore: turf, stone, and survival geometry. Let's start at the roots. Before modern civilization, Greenlanders didn't rely on insulation from hardware stores. Their homes, called ituki, were built from stone, whale bones, and turf. The secret of turf as an insulator is brilliantly simple. It's a porous material made of decomposed plants and trapped air. And air is the ultimate insulator. Thick sod walls worked like a complex thermos. They locked in internal heat and blocked hurricane-force winds. Even better, ancient Inuit built their entrances lower than the floor level. Why? So the heavy, cold air would get trapped in a pocket right before the doorway instead of rising into the living and sleeping quarters. Pure physics serving survival. No smart sensors needed. Architecture on stilt. Why aren't houses on the ground? Fast forward to the present day. Look at any modern neighborhood in Greenland, and you'll notice something strange. Every single house is elevated off the ground on stilts. Why do they do that? You'd think it makes more sense to press the house against the ground to stop the draft. But right here lies the main secret of Arctic engineering: permafrost. If you place a heated house directly on the soil, the ground underneath will thaw. The house will start to tilt, the foundation will shift, and the floors will constantly pull in cold and dampness. A 1 to 2 meter air gap beneath the building allows cold air to circulate freely under the floor, keeping the permafrost stable while isolating the house from the icy breath of the earth. What about the walls? Today, Greenland uses a multi-layered pie of insulation. The biggest challenge here is logistics. All materials have to be shipped in by sea, so every inch counts. Engineers use ultra-dense mineral wool or spray-applied polyurethane foam that expands right on site. The wall thickness in Arctic homes is staggering. Powerful barriers that turn walls into an impenetrable shield. Windows, airtightness, and fighting moisture traps. In a standard house, up to 40% of heat escapes through the windows. That trick doesn't work in Greenland. The standard here is heavy triple-glazed windows filled with inert gas argon and coated with a low emissivity film. Frames are fitted with surgical precision. The slightest gap in the frost turns into an ice crust. But here lies a trap people often forget about. When a house becomes super airtight, moisture has nowhere to go. People breathe, cook, dry clothes, and all that water condenses on the walls, breeding mold. That's why ultimate energy efficiency in Greenland isn't just about battening down all the hatches. It's a smart heat recovery ventilation system. The outgoing warm air transfers its heat to the incoming fresh, but cold, outdoor stream, taking back the degrees without mixing the air streams. The heat stays inside, while the air remains fresh and dry. So, what's the bottom line? The experience of Greenlanders proves that energy efficiency in extreme conditions isn't about buying expensive gadgets. It's a holistic approach: proper geometry and space zoning keeping the cold outside, cutting off ground chill with a ventilated foundation, insulation that acts like a thermos paired with smart ventilation. The harsh climate teaches one golden rule: the energy you don't lose is the cheapest energy you could ever generate. If you found this video interesting, hit that like button, subscribe to the channel, and drop a comment below. How do you battle the cold in your own home? See you in the next videos.